give it a shot.
And welcome to the
Pleasure to see you
afternoon
all.
session.
Thank you.
Just to let you know, the sign-up sheets are up here. You can come and sign after the session, so no worries there. I'm going to introduce our presenter. Corry Martin is the owner of CMP Enterprises Limited and has been in the trades of plumbing, heating, gas fitting, and ventilation for over 25 years. Corry is a dedicated trade professional with a wealth of knowledge to share. He has completed a provincial adult instructor's degree in March of 2017 and is currently involved in the program. Corry is a quality first TECA instructor. So without further ado, I'm going to turn the stage over to Corry.
Thank you very much. Okay, so thank you for the introduction. I am Corry Martin, journeyman plumber gas fitter since '99, owner of CMP Enterprises, and TECA member since 2000. Still a member, of course. And I also work for BCIT. I'm a piping trades instructor since 2015. Enough about me. Let's talk about what we do here at TECA. So what I'm going to discuss with you today is the ventilation guidelines course that we offer through TECA. And it's a really involved course, but it's a simplified guide to section 9.32 of our BC. Now, some of you guys may have done this course before or have been involved with other presentations that we've done for the BOAVC. Not a whole bunch has changed over the last little bit, but what I want to give you today is just an overview of the program, of the course that we offer, and how it can benefit, namely, you in the room who are the building officials. I want to go through it relatively quickly because at the end I do want to show you some new stuff that we're doing at TECA as well with our website and creating a resource library and database for the inspectors out there. At any time during the presentation I'm about to give you, if you'd like to stop me, ask me any type of questions, I'll do my best to answer, and I'm really fortunate that we do have some other TECA members in the room that might be able to help me if I can't answer your question directly. So with the ventilation guidelines, we as trainers, we create TECA Quality First ventilation practitioners. So what that means is we certify tradesmen and women to become certified as members of the residential HVAC trade. They'll be qualified to design and certify those designs of ventilation systems for residential dwellings. We offer the same course for all the building inspectors as well. So as if you are a building inspector, if you were to take this course, you could come through and learn all the ins and outs of how ventilation for residentially occupied buildings are supposed to work. Our goal at TECA is to see safe and efficient home comfort systems installed in residentially occupied dwellings, of course, in BC. It's done through training programs and efforts to achieve the enforcement of the minimum standards, and those minimum standards are outlined in our building code. The main purposes of our ventilation guidelines course is to understand the ventilation requirements, understand the appropriate methods of ventilation, to comply with the ventilation code as it's laid out in the building code, and also to design ventilation systems. It's quite an involved course. It's only a one-day course. Me as an instructor, I would love to expand it out to 2 days, but as you can imagine with trade professionals, it's really tough to get them to pull away from what they do for a living for more than 1 day at a time. So we get a lot of content in there, and it's a nice takeaway. I think David picked his up, but if you haven't seen it, we've got a really awesome manual, and this is the interpretation of the section 9.32 and 9.36 out of the BC. Awesome manual. If you haven't had a chance to look at it, definitely try to get your eyes on that. So when we start off with the ventilation guidelines, we have to ask ourselves initially, what is ventilation? And this is a big, long definition that I found on Wikipedia. It says ventilation is the intentional introduction of ambient air into a space and is mainly used to control indoor air quality by diluting and displacing indoor pollutants. It can also be used for purposes of thermal comfort and dehumidification. That's a big, long definition there. But what I tell my students that are coming in to learn it is that we, the practitioners, are responsible for this, for ventilation and providing safe, healthy, comfortable, and efficient environments to all of our clients. We really like to control indoor air quality. Bless you. So why ventilate? Well, this is a pretty standard question, and building officials know better than anybody why to ventilate. There's a lot of reasons why proper ventilation is such a big deal. And we really focus on this in the course that we offer. We really go through why we ventilate and what the reasons for it are. Primarily, we've got some problems with ventilation if we don't do it correctly. We have some dangers. But when we start to ventilate, what we're doing is we're displacing air from inside of a residential building, and we're bringing in fresh air, and we're doing that intentionally. We're intentionally introducing that air. But we have to watch out for some dangers of it. Some dangers of ventilation if we don't do it correctly. Well, here's a little clip that we've got from the National Cancer Institute, and it says that 80 to 90% of human cancer is determined environmentally. So let's take that into consideration, which means that cancer may be partially avoidable. Ventilation and keeping the air fresh inside of our homes is going to do a good job of keeping us very healthy. This isn't a new discovery either. If we go back here to a book published back in the late 1800s, they even talk about ventilation in the architecture of country houses. And they talk in there, there's no subject directly connected with domestic life on which there is so large amount of popular ignorance as ventilation. And that ignorance still is around quite a bit. There's a lot of questions about ventilation, how to do it correctly, why we do it. And basically we can answer those questions with the content that's in the course that we offer. This is the most extreme example. If we don't ventilate correctly, we can run the risk of carbon monoxide poisoning. This happens every winter. We hear about people getting gassed with carbon monoxide. This is not an old article. This is just from 2017. And this particular instance was a direct result of improper ventilation. So definitely that's the extreme example, but we want to avoid these types of situations. So when we talk about why we ventilate, the primary reasons that we ventilate these residentially occupied buildings is that we want to get rid of these primary contaminants. Moisture being a big one. We want to get rid of moisture out of our indoor air. Very, very important that we take moisture away. We know the results of long-term moisture, high humidity, indoor humidity. We've got some problems with that. Anything you can think of in the group? I'll pose a question. What are some of the problems that we have excess humidity inside of our homes? In the bathroom, yeah, we get a lot of excess humidity in the bathrooms if we don't ventilate correctly, get all that excess moisture out. What are some of the results of this excess moisture? You guys have seen it as much as I have, I'm sure. Mold is a big one, yeah. All right, I know you're all full and probably ready for a nap, but yeah, definitely moisture is a big one. We can have fogging windows, we can have mold, it causes respiratory irritation, a lot of problems with moisture. So that's really the primary reason why we're ventilating. Odor, another big one. We talk quite a bit about odors in the course, and we have a unit of measure for how much odor is produced, and I always get a good laugh out of this one, but the odor that's produced by people that occupy a building is measured in a unit called OLFS, O-L-F-S, plural. Typically, one OLF is produced per person per day just from body odor, and then other activities that we do inside of our homes produce more OLFs. The word OLF coming from the term olfactory, as in to smell. Pretty interesting. We want to make sure that our homes are attractive to be in, and bad odors are a big source of concern. Again, inside of our homes, we're breathing in there, and we're doing other things that produce carbon dioxide. We want to keep the oxygen levels up in our homes. We want to make sure that carbon dioxide gets exhausted. And a typical person, just breathing, produces about 20 cubic feet of carbon dioxide per day. And that's just at rest. If you're exercising or anything like that, you're going to produce more carbon dioxide. You're going to produce more odor as well. And you may produce a little bit more moisture as well. So well-designed and properly installed ventilation systems will take care of these. They'll replace that stale, moist air with fresh air without compromising occupant comfort. When we look at our indoor humidity levels, we've got some safe ranges or some comfortable ranges. We have this ideal range for people that's in here, somewhere between the 40 to 55-ish sort of percent relative humidity, based on whatever temperature we like to keep that home at. So typically the comfortable ranges are 17 to 25 degrees, depending on who's living in the home. That's in Celsius. And then the relative humidity is somewhere between around 40 to 55%. Ideally, somewhere in this range, around the 20 degrees Celsius at 45 to 50% relative humidity. So we want to try to fall within those ranges with our indoor environment. If we get too dry, we run the risk of other uncomfortable situations for the occupants. Viruses tend to breed in dry, low humidity environments. We can get some respiratory irritation, eczema, exasperation, and the like. And then we start to get into high humidity. We run the risk of mold, moisture buildup inside there. Also breeds ground for dust mites, which is a lot of people are very, very allergic to dust mites as well, so you have to watch for that. But this is our ideal range for people, is somewhere in this area here. And you probably already know that, but the ideal range for people is what we're targeting for when we ventilate. We're trying to get rid of that excess humidity, and we're trying to maintain a comfortable indoor temperature. So we got some other pollutants that we talk about relatively extensively in the course as well. Indoor sources of pollution. And I got a really good infographic here from, where did I get this one? Oh, this is from How Stuff Works. It's a website that has some free resources for us. And we talk about indoor air pollution. We've got a number of different areas, especially in new construction and new builds. All of those products that we're using to build these new residences, they all have some sort of impact on that indoor air quality. Whether it be the amount of moisture that gets introduced to the space because we have a product that has high moisture levels, like drywall mud and tile cement, paint, for example. These all have lots of moisture in it, so we want to get rid of those. But we also have some other sources. We have carpet being a big source of chemical contamination. Radon, I know some parts of the province have a lot of issues with radon leakage, radon coming in, infiltration into buildings. Pesticides, maybe not quite so, maybe not quite as obvious, but pesticides get tracked in every time you enter your home, and anyone that comes in can track pesticides in with them. We also have combustion byproducts, whether we're cooking with gas or we have gas appliances, gas fireplaces, and the like. Combustion processes can lead to some harmful contaminants inside the building as well that we want to make sure we're ventilating and mitigating. Household products, these are a big one, and this is something that I've been looking into more and more, and working with other parts of industry to find out what type of contaminations are showing up in homes when we start to combine household products. You know, we look at a lot of our household products, things like bathroom cleaners, window cleaners, all these different chemicals, these chemical compounds that we're bringing into our homes. That compound on its own may be very, very safe or may not be very reactive, but we start to mix these compounds together, and there's an unlimited amount of secondary compounds that can be created. So ventilation is really key in making sure that we're getting rid of a lot of these contaminants. Lead, well, we're really on the warpath for lead these days, but lead does exist in older homes and in a lot of consumer products to a certain level. Lead, if there's a product that contains lead, that lead can become airborne as well, and we want to make sure we mitigate that. I've got down here as well environmental, and it should say environmental and tobacco smoke. So environmental smoke, like from forest fires, there's a lot of people here from outside of the Lower Mainland. It's a big problem. We want to do our best to try to ventilate and take care of those types of that type of smoke as well. And then other biological contaminants. And the big one with biological contaminants is the fecal matter that we track in. I mean, this is everywhere, and whether it's in the form of a fertilizer or whether it's some sort of effluent, that type of material can come into our house. Namely, we track it in from outdoors. So we want to make sure that we're ventilating to try to mitigate most of these contaminants. There's me. I don't want to be that person who has to tell you that your house stinks. So that's why we ventilate primarily, is to get rid of that moisture and to make sure our indoor environments are very, very comfortable and fresh. I'm going really fast. At any rate, we have 4 common and accepted ways to ventilate these residentially occupied buildings. Pretty common way. These are all building code accepted methods. These methods you'll all find in the BCBC. However, you'll find them very detailed and a lot easier to comprehend in our manual. The building code is a great outline. However, we've really got all the details in our manual to allow you to dig into it and see how these systems are to be assembled, how they function, and how they're sized, being a big part of it. How do we make sure that we've got the proper rate of ventilation for that particular building? So I'm going to talk about these for a bit, and if anyone has any questions, please don't hesitate to stop me. I know I go relatively quickly through this stuff, but what we're going to do is we're going to take a look at the 4 TECA-approved, building code-approved methods of ventilation. And I do know that there are some municipalities that have kind of manipulated those a little bit and changed them to suit their own needs, which is fine. But I'm just going to stick with the TECA-approved methods. So we've got forced air systems, and this is probably one of the simplest ways to ventilate a residence is using a forced air system. Now you have to have a forced air heating system, heating and cooling. Forced air heating and cooling systems, they have ductwork. The building code prescribes that we have to supply fresh air to every bedroom, and typically we supply that fresh air with the heating system, or the heating and cooling system, if you will. So if we're going to ventilate, it makes sense for us to use the existing ductwork that goes along with that forced air heating system. And I'll show you how that goes together here in a minute. We also have HRV systems, and if you're not familiar with an HRV is a heat recovery ventilator. And there's different types of HRVs. There's another system called an ERV, which is similar to an HRV. They perform a similar function, and what they do is they draw out stale air and replace it with fresh air. HRV systems can be paired off with your forced air heating system and utilize the ductwork that is supplying all the conditioned air inside the space. It can be paired off with a forced air heating system, or it can be a standalone system. It can be a system that is ducting fresh air out to all of the bedrooms independently, and has to exhaust from at least one point inside the building. A lot of installers will exhaust out of all the bathrooms. What they'll do is they'll split that exhaust rate up and they'll exhaust from bathrooms. And the nice thing about doing that is when they exhaust from a bathroom, the HRV is going to run continuously, and you're going to be continually drying those bathrooms out. Works really, really well. We also have systems called CRV Systems, and this is a central recirculation ventilator. And CRV system is a little bit different than an HRV, as in it doesn't provide us really any method of extracting any heat energy from our exhaust products. I'll step back a bit here. An HRV system, heat recovery ventilator, the beauty of it is that as we exhaust conditioned air that we've already paid to either heat or cool, as we exhaust that stale air from the building, the heat recovery ventilator can perform a function where it saves some of that energy, where it'll actually take some of the heat energy out of that warm air that we're exhausting to the outside, and it'll transfer that heat energy over into the fresh air that we're bringing back into the building. Fabulous setup, works really well. A CRV doesn't quite do the same function. It provides us a good exhaust. It also provides us good fresh air, but it doesn't take advantage of any energy benefits that an HRV may do. And I do know that some municipalities have adopted HRV only for all their new construction builds for ventilation. That makes really a lot of sense to use an HRV if you're trying to get to a certain level of step code. HRVs are very, very good for that. But one thing is it doesn't matter what type of ventilation system that we use, there's always some sort of an impact on energy consumption. We're always going to have to use some energy to provide ventilation, whether we lose it to the outside by exhausting air that we've already paid to condition, or whether it's from running fans or electrical consumption, things like that. So there is definitely an impact when we talk about ventilation, but we want to make sure that we keep that impact as small as possible. Our final system is a passive inlet system. Not to be confused with a passive home, but this is just passive airflow that allows fresh air to migrate into a building naturally through inlets or air openings in the building that we install. Any questions so far? It's pretty basic stuff. So let's take a look here. This is a page right out of one of our manuals. It looks like there's a lot of information here, but it is actually pretty straightforward. A forced air heating system. This is all based on right out of the building code. You can refer back to the BCBC right there. Per sentence 9.32.3.4, section 2, it describes the application for a forced air heating system ventilation setup. So what we have here is a real basic 2-story home, and our example shows we have one principal exhaust fan. Now typically these are installed as a bathroom exhaust fan. You probably know that. We use these principal exhaust fans to exhaust the stale air out of the building. Now previously in codes prior to the most current, we were allowed to run this exhaust fan 50-50. We could have it on and off throughout the day. It was up to us as an installer to decide how we would control that exhaust fan, but we had to have it running at least 50% of the time. That particular section of the code has been changed now. We want to provide continuous ventilation. We provide continuous ventilation because we found that A, there's a need for it. We need to make sure that we're ventilating continually. And what we also did was we scaled back slightly on the ventilation rate so that we could allow for that fan to run 24 hours a day, 7 days a week. Like I said, typically this is a bathroom exhaust fan. This will be installed in a bathroom and it will run continuously. There are some fans out there that are available that will be able to set up to run so that they can run at the prescribed ventilation rate, which may be very low. If it's a small building, the rate of ventilation may only be 35 cubic feet per minute. It's a very, very small ventilation rate. However, the building code prescribes that a bathroom must have a minimum of 50 CFM in an intermittent capacity. So what we do here is there's some fans out there that are available for us that will run on multiple speeds, but what we want to make sure is that when it's running on this low speed continually, that it meets the prescribed ventilation rate, which you will find in the BCBC, and you'll also find that code table in our manual. So simply enough, we've got all of our stale air exhausting out through one bathroom exhaust fan, and we're bringing fresh air in from the outside, just passively, connected to our return air ductwork for our forced air heating system. And it looks something like this. What happens is this forced air furnace is set up so that the furnace blower motor, this is the fan that's moving the conditioned air throughout the building, that furnace blower motor is going to be running on its lowest speed setting possible, and it's also going to run continuously. So what happens is it draws its fresh air in because it creates a little bit of a low pressure area inside this ductwork. This fan is really, basically it's creating low pressure by sucking air through the return air ductwork. And when it does that, that lower pressure gives us the ability to tie a duct from outside into it and draw that fresh air directly into the return air plenum of the furnace. That indeed brings in enough fresh air for us to satisfy the ventilation needs for the home. However, there are some energy impacts with this. We're running a fan here, our principal exhaust fan, that's running 24 hours a day, 7 days a week. There's an electrical cost to that. As well as the furnace blower motor running on low speed also is going to burn up some power. So that's going to have another impact to our energy consumption. And finally, we are exhausting air that we've already paid to condition. So whether we've heated that air in the winter or cooled it in the summer, there's a cost to that as well. So we don't want to overventilate. It's a big concern of ours. We don't want to overventilate. We don't want to waste that energy, and we want to make sure that we're meeting the minimum rate so that we can keep that building envelope fresh and healthy. There's a lot of rules and regulations that go along with how this system is set up. This is just a simple overview. But the forced air system, this is probably one of the most common types of ventilation systems that you'll see set up here in the Lower Mainland. Very, very common. Outside of Vancouver, of course. Vancouver, I believe, has adopted going with HRV only. But the nature of this forced air system is very simple for the contractor to understand, and it's very simple for the municipal inspector to look at and make sure it's set up and done correctly. Here's a little look at our HRV systems. The HRV systems, again, right out of the building code, it talks about the HRV system and how this is set up. Well, there's two options here. We've got our example 2A, which is an HRV system, which is set up with a forced air. So you can see, very similar system here. We've got a furnace. We've got this supply trunk coming off the top, or the supply air. This is the air that's been conditioned, that's going to be distributed throughout the building. There's our return air. Same thing goes with the HRV. We've got a furnace, we've got a return air, and we've got a supply air that is distributing the airflow throughout the building. Again, the furnace blower motor must be set to run continuously on a low speed. However, rather than just having a passive ductwork that's bringing in fresh air from outside, we've got the HRV that's actually doing the function of bringing in the fresh air. That HRV is going to bring in fresh air from outside, and it goes through a heat exchange process where that cooler outdoor air can be tempered or warmed up with the air that we're using, our stale air that we're exhausting. Like I said, there's a lot of heat energy stored in that, and as that heat energy transfers through the HRV's heat exchanger is going to strip away some of that heat and bring it into our fresh air coming in. So it is good for saving a little bit on the loss from the exhaust, the lost heat or the lost energy, if you will. However, we are running another fan. So we've got, typically HRVs have two fans in them, so there is another electrical impact with that. We've got the electrical impact of the furnace motor, but we don't have a principal exhaust fan anymore. Our principal exhaust fan becomes that HRV. That's a system paired off with a forced air heating system. Now if you look down here, I've got a HRV with ducted ventilation. So this is an HRV that's standalone, and we're going to see these more and more often in homes that have an alternate form of heating, whether it's electric baseboard, hot water radiant heat, heat pumps, things like that, where there isn't a distributed heated air system. It's going to be some other type of heating system installed in the building. And these HRV systems, standalone like this, again, very, very good for providing nice fresh air and to minimize that energy impact of exhausting conditioned air to the outside. The other type of unit, like an HRV, there's another unit out there called an ERV, which stands for Energy Recovery Ventilator. Well, the HRV, it does a really good job of stripping the heat energy directly out of the air that we're exhausting to the outside. Does a great job of that, about usually somewhere between 50 and 60% effective. An ERV is slightly more effective because it has a heat exchanger that has what's called a semi-permeable membrane in it. It allows latent moisture or water that's in its vapor form to pass through. Some of that water can pass through the heat exchanger. Latent moisture, when it's in this airflow, contains a lot of energy. So when we allow some of that moisture to actually pass through into our fresh air that's coming in, we're going to collect a little bit more. We're going to pick up a few percent of efficiency on that type of unit. Not every building is perfectly suited for an ERV. ERVs and HRVs are very unique in the way they operate. If you need to dehumidify, you should stick with an HRV. If humidity is not such a problem, or if you want to maintain a certain level of humidity inside of a building, ERV is maybe a little bit better way to go. Buildings with lots of wood builds. If you've got a lot of interior trims or wood floors, cabinets, wall finishes, we like to keep a little bit more moisture inside those buildings, so an ERV may be a better fit. Talk to your ventilation contractor. This is a quick look at our CRV system. The CRV system, again, these are another accepted from the building code, another accepted method for ventilating. A little bit more specific of where we can use a CRV system. We can use these with all types of heating systems, but it's typically non-forced air. If you have a forced air heating system and you want to do a simple ventilator, why would you bother going to the extent of running more ductwork than you need? You would just typically stick with the system 1, which is forced air, or a system 2 with the HRV tied off to the forced air. But the CRV is actually a good way to ventilate, typically for smaller builds, but we allow them for all dwelling unit sizes. We can use them in all locations. Typically, in a coastal climate, there's, I'll explain this a little bit. We have two different applications, a coastal climate application and a cold climate application. The reason being is that you can imagine our wintertime lows on the coast are a lot warmer than they are in the colder climates. So the way the system works, it's pretty straightforward, but the way it works is we have one fan that's delivering fresh air to bedrooms or exhausting stale air from bedrooms. I can see this methodology going away eventually, but basically the way this works is that we're drawing fresh air in from outside through some ductwork, and we're also drawing stale air in from somewhere inside the building, usually a common area. What happens is we take these two airflows and we blend them together. We blend these two airflows together to produce tempered air. You can imagine if we're drawing fresh air in directly from outside and piping that directly into bedrooms, that we're going to get some complaints. We're going to have some homeowners that aren't going to be very happy, especially in a cold climate when we've got below freezing air blowing into their bedroom. Not a good scenario. So what we do is we take a mixture of fresh air from outside and stale air from inside the building, and we blend those two in what we call a fresh air mixing fan. That fresh air mixing fan is going to deliver that mixture of air to the bedrooms, and we're going to get our fresh air delivery in that way. On a coastal climate, this fan has to be sized 2 times larger than our principal exhaust fan. Now, the principal exhaust fan shown here is the same type of setup as we have in our System 1. Okay, our System 1, we go back, has a principal exhaust fan that's continually running to exhaust stale air out of the building. So it's the same setup. We're exhausting out of the building, but we need to bring the fresh back in. So what we're doing is we're setting up a dedicated fan that's going to do that. On the coast, this fan is going to be 2 times the capacity of this fan. So for example, if we were to look it up in the code tables in the BCBC, it would tell us based on the size of the home, how many square feet it is, and the bedroom count, that gives us an idea of how many occupants are in the home. Based on those 2 criteria, it will give us a rate at which we must ventilate, whether it's 50, 100, 130 CFM. That's how many CFM we're going to have to exhaust at. So this fresh air mixing fan, if this was 100 CFM, this fresh air mixing fan on the coast would have to be 200 CFM. Because on the coast we can take a 50-50 mix, and that's good, even on the coldest day of the year. However, when we get into cold climates that their wintertime low is less than +5 degrees Fahrenheit, we need to increase the amount of interior air that we use, that we blend with that fresh air from the outside. And the way we do that is we use a larger mixing fan. So what happens is that in those cold climates, this mixing fan would have to be 3 times the size of our principal exhauster. So 3 times the size, if this was 100 CFM, if that's what the code prescribed, this fresh air mixing fan would have to be 300 CFM. A system like this is not without its downfalls. Again, we are exhausting conditioned air directly to the outside. So we have an energy consumption there, an energy loss there that we could avoid if we did a different type of system. However, this does work fairly well. This fan has to run continuously also, so there is an energy impact with running that fan. We've got some electrical consumption. And we also have a lot of electrical consumption with this fresh air mixing fan. This fresh air mixing fan is going to consume a bit more energy, namely because it's 2 times the size of this fan, but it's going to consume more than 2 times the electricity because it's ducted on both sides. There's going to be an impact to how much energy it takes to move that air. Typical bathroom exhaust fans, they are ducted on the exhaust side. However, typically they're an open grill in the bathroom, so there's no ductwork connected to them on the inlet side. So like I said, the code prescribes for us to deliver fresh air to every bedroom. This example 3B shows us doing just that. We're delivering a fresh air mixture to each bedroom. However, this example 3A is the reverse of it, where we are drawing stale air from bedrooms, we are drawing fresh air from outside, and we're delivering that mixed air to a common space. Both of these are currently acceptable. However, if you do dig into the BC Building Code, it says that we're to provide fresh air to every bedroom. Well, in a roundabout way, this system will provide fresh air to the bedrooms. Hopefully the doors are undercut enough to allow that air flow to return to those bedrooms and to get some fresh air in there. However, I can see this system in the future possibly being less likely that it'll make it back into a building code. Only because of that we're not directly delivering fresh air to bedrooms. Pretty good system. I haven't actually seen a whole bunch of these installed in the Lower Mainland, not for a long time, but we do see these in some of the few other areas. I've seen a couple of these in Whistler, but I haven't seen a whole bunch of them. Our final accepted system, TECA accepted system here, is a small dwelling unit with a non-forced air heating system. So this could be a dwelling unit, maybe a single detached, so it might just be a really small home. Might be a laneway home, or even a secondary suite within a primary dwelling unit. It also may be a single dwelling unit within a multi-unit residential build. This system is very specific to the criteria of where we're allowed to use it. Primarily, the winter design temperature has to be warmer than -4 degrees Fahrenheit. The dwelling unit size itself has to be 1,800 square feet or less. It can only be 1 story. And they're non-forced air heated with no exterior chimneys. So what this means is we don't want to run the risk of having a B-vented appliance or something like that that could cause some sort of a problem with the way the function of that atmospheric or of that NAFA appliance. So we have gas-burning heating equipment or gas-burning water heating equipment. If they are, if they're not sealed combustion, they're not a good fit for this. You are allowed to do it, but we have a caveat we've written in down here where TECA strongly recommends against NAFA installations in example 4. These type of dwellings, NAFA being naturally aspirated, fuel-fired vented appliances, and we'll talk about those a little bit as well. But there's a lot of criteria in regards to these small dwelling units. It has to have dwelling unit sizes 1,800 square feet or less, only on 1 story, and it's a non-forced air heated with no exterior chimneys. Well, there's a couple reasons here. We really want to make sure these systems are installed on 1-story units because the way they work. The way they work is that we have a principal exhaust fan, typically a bathroom fan, that is going to be exhausting 24 hours a day. The way that fresh air makes its way back into these bedrooms, if you look here on this little floor plan that I have here, the way that fresh air makes it back into these bedrooms and back into the common area is just with a single opening right through the building envelope. There's no fan bringing this air back in, there's no ductwork attached to it. All it is it's 1 air inlet into each bedroom, and that air inlet has to have a minimum of 4 square inches of free area. That means that's the total opening that we can see through. It has to be 4 square inches. And it allows that fresh air to migrate directly into those bedrooms. We're very specific about where we want them installed. We want these installed at a minimum of 6 feet off the floor. These fresh air inlets have to be a minimum of 6 feet off the floor. The reason for that is that if we're allowing fresh air to migrate into these bedrooms, if we allow that cold air to migrate into the high level, hopefully as it comes into the room, it'll mix with the warmer air, which will be higher in the room, and create a blend of fresh air and of interior warm air so that it is less noticeable to the occupant. You can imagine if we brought that fresh air in down at the baseboard level or at knee height, that cold air is going to create a cold air barrier. It's going to be very uncomfortable for the occupants. We want to make sure that we keep those at 6 feet off the floor. And I'm very particular about this type of system because I don't want that fresh air grill or that fresh air inlet to be installed somewhere that the occupant is going to be using that space. Like I would really hate to see it come directly into where someone has a desk perhaps or right over the headboard of their bed. We'll try to keep it kind of tucked away. It's very critical that you choose these locations wisely, namely because most of the systems that I've seen installed, when we go back for service at a later date, you see a lot of duct tape taped over these fresh air inlets because people don't like the draft. So you really have to watch for that. What they've done is they've totally, they've shut their ventilation system down as soon as they do that. So these systems are really subject to being disrupted and not providing the ventilation that they're intended for. So it is very important that the installer pay close attention to the location of these fresh air inlets. The other reason is, another criteria is that we have it set up to be on 1,800 square feet or less and on one story. Well, if we get too large of a building, we may get other things happening where one vent may start to allow air to flow out of it rather than fresh air come in. We get too large of a residence. Or if we have multiple stories, if we put this type of a system in a 2-story building and we have vents on both stories, what's going to happen then? We're going to have the vents on the lower stories are going to be bringing fresh air in, and the vents on the upper stories are going to allow that air to migrate to the outside. So it will definitely contravene the intention of the system. So 1 story only. But I have seen this system installed in locations where there is 1.5 story, or basically like not a split level so much, but perhaps there's a small living level, and then the upstairs they have had passive vents on. I've seen it installed like that, and that's exactly what happens. It's those lower level fresh air inlets. They allow fresh air to rush into the building, and the upstairs inlets in the upstairs bedrooms, they turn into exhaust grills. They don't actually allow the fresh air to migrate correctly. So you have to be very, very cautious of that. What else did we talk about here? So the fresh air comes in, it has to come into those bedrooms, and it also has to come into one fresh air inlet into any part of the common area or living space. Really important that we have that final grill to allow that fresh air to come in, so that the whole building gets some nice fresh air coming into it. We talk about NAFA appliances and combustion air. NAFA appliances, and we're going to talk about these next. They create some problems when we have these type of a system. Namely because what will happen is these fresh air inlets can start to do things like provide combustion air to these appliances, and we don't want that to happen. What we want to do is we want to make sure the mechanical equipment is getting air from the sources that it's intended to. Do I have stuff about NAFA in here? I should have. So we looked at those 4 systems there. Just to quickly recap, the 4 that we have are the forced air heating system, which I'm sure most of building inspectors that are inspecting this type of project may have seen. HRV Systems, CRV Systems, and finally this small dwelling unit with non-forced air, or what we like to call as a passive system. It's not technically passive because we are exhausting with the mechanical fan there, though. Any questions on those 4 systems? Everybody seen them all? Yes.
The CRV system where you're putting air into the vent.
Yes.
The code doesn't address it. Is there a recommended length where you're mixing the air before it gets?
Actually, in here we talk about it. The recommended length for this ductwork. Is that what you're talking about?
No, from where the 2 mix together.
From where the 2 mix together to the actual outlets in here. You know, the code is pretty silent on that. It doesn't prescribe to us exactly how to set up this ventilation system, but I hear what you're saying. If this connection was right off of the fan collar for the first bedroom, that bedroom would get probably 90% of the air, and further down the ductwork, if these are quite a bit further away, they would get far less.
So it doesn't get a chance to mix as much.
Doesn't get a chance to mix as much, exactly. This here, basically the way this works is that it gives us, we prescribe the size of the ductwork that has to bring the fresh air in from outside. You can use 4-inch rigid duct to bring the fresh air in from outside, or 5-inch flexible duct. Of course, since it's carrying unconditioned air, it needs to be insulated correctly so we don't have a sweat problem. But that duct that comes in, we have figured that with the connection to the back of this fan, this fresh air duct that comes in can be connected anywhere to this ductwork, and it makes very little difference to the amount of to the volume of fresh air versus stale air that we're getting. However, absolutely, the fresh air mixing fan, the longer the ductwork from the fresh air mixing fan to the first connection, the better the mixture is going to be, for sure. Definitely, it's a good question. Does that answer it, though? Okay, good. Good deal. These small dwelling unit systems like this, again, what was I going to touch on with these? There is, with any type of ventilation system that we use that is taking advantage of a principal exhaust fan. These principal exhaust fans, I keep saying that they should be installed in a bathroom. They don't absolutely have to be installed in a bathroom, but it makes the best fit. You're putting a bathroom fan in anyways, so why wouldn't you use one of those fans to be your principal ventilator? Well, this principal ventilation fan, a couple things you have to keep in mind. One, we want it to be energy efficient. We want to put in a good fan. The other thing is, too, is we have to make sure that fan is not too noisy, right? There is a code requirement that that fan cannot exceed 1 zone of noise allowance. It can't exceed 1 zone. Zone's a measurement of sound, and if it exceeds 1 zone, it's not acceptable. It's not an acceptable fan to use as your principal exhaust fan. And the main reason is because if it's noisy, people will try to shut it off, right? The other thing is too is I like to see installers. I like to see contractors that are installing those principal exhaust fans. I like them to try to pick a bathroom. I know we do in our outfit. We try to pick a bathroom that is not a bathroom that is, well, typically not the master ensuite, because the ensuite or the master bedroom is usually occupied the most, and quite often those bathrooms are large bathrooms as well. So maybe you want to have a bigger ventilator and a bigger exhaust fan for the moisture. But again, that's totally, the code's silent on it, but the installer should probably keep that in mind, because we really don't want to see people, we don't want to see them do anything to their ventilation system that's going to compromise it. We don't want to see them shutting these fans off due to too much noise, or if they're annoyed with the ventilation system. We want to make sure that they're running continuously. All right, so our ventilation guidelines certification program is designed to clarify those minimum building code requirements, designed to provide symmetry from design through install and inspection, and also to drive industry standards and practices. So the whole point of what we do at TECA is to make sure that these systems that are getting installed meet the building code required minimums, right? And we want to make sure that the contractors that are doing the work know what they're doing, and that everyone else involved with the process also knows what these standards are. Our guidelines certification program provides uniform design and permitting processes. Excuse me. I like this a lot because the uniform design starts off with the installer or the contractor who can use the TECA provided worksheets to help him or her design the system that they're going to install. Helps them come up with a suitable ventilation solution for the residential build that they're working on. And that process of design will turn into an inspectable system for everyone involved, whether it's internal inspections from quality control within that contracting outfit, or whether it's municipal inspections. The paperwork remains the same all the way through, is what I'm trying to get at. Our forms are also really easy to follow, and also our installation guidelines are quite easy to follow. We have flowcharts and systems inside the book that allow any contractor that knows how to use this book, or anyone that knows how to use it, to go through and find the system that is going to work best for them and make sure that it's sized and installed correctly. We also like it because it provides us some standardization for industry. So it doesn't matter what municipality you're working in or where you tend to be doing your installation. This manual and our building code will support you throughout the whole province. And I really like the system summaries at the end that give us as something that we can use to inspect and really streamline that process. How many building officials in the room, anyways? Okay, I'm outnumbered. All right, that's fine.
What do you mean by inspectable system summaries?
Inspectable system summaries. Have you seen our worksheets?
Oh, yes.
You've seen our worksheets. Well, that is what I like to see. That worksheet, in turn, that the contractor turns in to the municipal authority, the AHJ, turns it in. That should become your inspection worksheet. That should be on site when you're doing your building final walkthrough before drywall or before installation, whenever your municipality says that you need to be looking at that. That worksheet should be your guideline. You should be able to go through and confirm that the fans are installed, that the ductwork is sized correctly, and that the contractor actually has a clue of what he is doing, or her is doing. Do you agree or not agree?
Just the ductwork is never
That's the problem. That's where your biggest problem is going to lie, is making sure that the installer has done a proper design based on how it's actually getting installed. Although this is where the hiccup comes in, right? We've got a blueprint. I'm the contractor. I've got a blueprint. I can only assume so much. I can say, well, I'm going to run the ductwork here. And then it gets framed. And then we show up, and we don't necessarily run the ductwork exactly as what we had planned in the beginning. So is there a revision process? How does what's the solution? Don't get to carry on until we get a correct worksheet. What other option is there? Really, I mean, you have to say this is what you've designed, this is not what you've installed. They have to match, right? They have to match. I have seen some municipalities adopt the method of installation by declaration, where the installer says, yeah, we did this correctly. I don't think that's really the answer, but I think the answer is making sure that building officials are well versed on how these forms need to be filled in, and then being able to identify what you're looking at on the job site. Outside of that, I think that the more scrutiny you have when you're looking at these applications, and the better job that gets done on site is going to make sure that these ventilation systems are coming together the way they're supposed to, right? It's tricky though, especially if you've got a contractor that has run all of his ductwork based on the sizes that are on his worksheet, but he's got more length and more elbows, and maybe he's sizing correctly. Yeah. No, it doesn't. But it doesn't say 5. Whether or not he uses the tables that are directly out of the ventilation guidelines book, whether he uses the POMA information, or whether he or she uses a ductilator, that will tell them that their ductwork is incorrectly sized. That's the biggest hurdle that we have to overcome, is making sure that the installers can identify, hey, I've got a worksheet here that says I'm allowed 4 elbows on this run, but I've got 6 now. What's the implications of that before the work gets done? So we have seen that issue arise quite a few times. But in the field, as inspectors, that's what you're there for, right? You're there to make sure this stuff gets done correctly. And I really like the fact that you're taking notice and paying attention, and not just saying, oh, there's some ductwork run. It's it's super important. These ventilation systems are a big part of the healthy interiors that we're trying to provide to our clientele. So I think that's great that we're calling people on it, right? You can't just let the stuff go. Of course, you wouldn't ever do that. But the nature is that it can create a lot of conflict too, right? So contractors don't like to redo work, but if it's not done right, that's what we have. That's what we have an authority having jurisdiction for, is to make sure this stuff gets done correctly. Anybody else had similar issues like this, where you've seen the worksheets don't match up with the actual installation? Only one. I'm surprised. Everybody sees it, right? You've all seen it. You've all seen it. So what are some of the other scenarios that are happening out there then? Namely, that's what's happening, is that typically the paperwork has to get turned in. Is it getting checked through the plan checking processes? Is it coming in with the framing inspection? Yeah, so at that point, if it's coming in with the framing inspection, the installer should have already had a pretty good idea of what that system should look like, and his ductwork should be sized correctly. However, it's coming in at the building application process. Well, the building's not even framed yet, so that's kind of a shot in the dark.
Yeah, and I do my market's all spec homes, so to speak, and they have always let out the contract for the heating ventilation, so I asked for the mechanical ventilation checklist prior to booking the frame. Then you get up there, and then they have their trunks and everything around, and they have those little flexible ones. I'm not a sheet metal guy, but it looks snake sometimes, This looks like it's going to push a whole lot to me.
You got to be careful with flexible duct for sure. Question back here?
I was going to say, one of the challenges we run into the forums is sometimes the CFMs of the units that are going to be installed don't line up. Most common one is the kitchen exhaust fan. So if we're doing renovations with naturally aspirated appliances, that becomes a concern for us. So we actually take our checklist back. We're trying to sometimes back up the finals, double check that new fan, kitchen exhaust fan hasn't run
Exactly. You know, and that's a challenge too from a contractor's perspective. I've been a contractor for a long time, and you know, quite often, either myself or electrician we work with provides the bath fans, but usually whoever's speccing the kitchen appliances is providing that rain shed, right? They're providing that kitchen exhauster. And at the beginning of the project, we need to know what size ductwork to install, and we need to know if we're going to have a problem if we've got naturally aspirated appliances. So we need to be able to identify these things at the beginning. And I can count probably, if I use all my fingers and toes, I could count a lot of times where I've shown up and I've roughed in ductwork for 300 CFM, and I get there and it's 1200 CFM or it's 800 CFM. And it's like, well, it was a good deal. Well, it's a good deal, but we've got some other issues to deal with now. Namely, you know, are we going to create a negative pressure situation? Are we going to start exhausting out of that building so much that we're going to have air rushing back in wherever it can? And if we've got those naturally aspirated or thermally buoyant appliances, are we going to have a problem with that, right? And that's the big kicker for sure. You know, great point. Me as a contractor, quite often when I'm working with my GC, I will go through that worksheet, and when it comes up and says, hey, what's your exhaust appliance? I have to list what the kitchen exhauster is on that worksheet. I make sure that my general contractor knows that, hey, if there's a problem here, I'm not on the hook for it, you are, right? Because makeup air isn't cheap. You know, especially when you get into some of these cold climate areas, right? You get up into the Okanagan and that, you may need multiple kilowatts of electric heat. It might not even be available to you. You may only have a 100 amp service, and you might need 60 amps of it dedicated for a makeup air heater. So there's a lot of pitfalls to the ventilation system if it's not designed and then adhered to through the construction process, by all means. I love hearing these type of stories. Anybody else got anything to add? Please, I love it. Oh, I've run across that with heat loss calculations for radiant heat.
Get lots of checklists maxed out at 75 CFM because they're still stopping at, 3 or 4 bedrooms at the time, and the maximum flow rate of 75 CFM. We're still getting that.
Are you seeing current stamps on those forms though?
Oh yes.
So
2012.
Wow.
Not just a few.
More than the occasional one. You see, that's a problem too, because the code has changed, and even if they're certified, you know, it's changed a long time ago. And if they're carrying a certificate and they're designing and installing these systems, but they're not adhering to what the code prescribes, that's your guys' job to stop them in their tracks, I suppose. I mean, it's all about education too, right? I mean, if you fail a guy a couple times on this, I know as a contractor, when I get, for lack of a better word, when I get busted or roasted on something that I didn't do correctly, it might happen once, it might happen twice, but it's not going to happen again after that. You learn your lesson pretty quick when it comes out of your pocketbook, right? To do the repair work. So that's another dicey thing, though. I mean, to find a ventilation checklist that was just a copy of an old one. Is that what you said happened? Something from 2006?
Well, yeah, I mean, it wasn't even done in 2012 cold cycle vent home in 2014.
Wow.
It was from 2006.
Wow. You need to redo this at this point. Well, we've got some stuff in the works to hopefully really help the building official. I'm gonna dive into that in a couple minutes with you guys, just in regards of what we're coming up with at TECA to hopefully help a teensy bit with the difficult job that you've been tasked with, because I can't imagine it's easy. I think I would much rather stick to being an installer than having to be the authority. It doesn't look like an easy job. So you have a high level of respect for you men and women in that particular job. So that's what I was talking about, inspectable system summaries. I like it. If there's suggestions that you want to make from the building inspector standpoint, from the authority having jurisdiction standpoint, let us know. If there's anything we can do to make it easier for you or to make it better, I've got my suggestions that I've pushed into the ventilation committee, but if you have suggestions, we want to hear from you. You know, you're just as important as the tradesmen that are installing these things, right? And probably more important because you're the gatekeeper, making sure that it gets done correctly, that this stuff doesn't get through. So I like the ventilation guidelines program, the workflow of it. The designer completes an appropriate worksheet follows the worksheet direction. Inspectors will follow up on the summary, and the summary becomes part of the permitting process. That's the nature, that's the intent, and as we're finding out more and more, maybe there's a few issues with that, but hopefully working together we'll be able to solve those problems. These systems are designed for new construction and renovation markets. The installer will follow the direction, and inspectors follow the summary. And we've got some examples of our content. Well, again, there's the overview of one of our application. We've got lots of explanation drawings in our manuals. If you haven't seen our manual, definitely take advantage of it. Have a look at one. We've got code content. So this is material that has been interpreted from the building code and put right into our manuals. We also spend a lot of time on appliance identification, really super important, especially in the renovation market, but super important that HVAC contractors can identify what type of appliances they have, whether they are forced draft or whether they are natural draft. Those are the primary differences. I'm not going to really dig into it too much, but we spend a lot of time in the course. In a 1 hour course to spend, or in an 8 hour course to spend 1 hour on this is actually a lot of time. And we really hope that our sheet metal contractors out there that maybe don't have as much to do with the appliances can at least identify what's in these builds. Really important. We get into how all these appliances work and what the dangers are of dealing with naturally aspirated appliances. Really big issue with us at TECA, me in particular. I think this is a really hazardous condition, and I really drive it home when I'm the instructor. We talk a lot about climate zone and energy considerations in the course as well, and we actually take more excerpts directly out of 9.36 out of the BCBC and apply it to our ventilation systems to make sure that we're not wasting any excess energy. We got these lovely worksheets that we just spent a few minutes talking about that I think are pretty handy, but if there are changes or things that we'd like to see with these worksheets, you as the building official, please give us your input, and we will do our best to accommodate you. Yes, in the back.
Touched on natural draft appliances.
Yes.
Lucky's house now in the spice kitchen. They're putting these commercial grade hood fans in. Sometimes the burners don't even turn on because they're like 1200 CFM. Does your course teach you to compensate for that hood fan sizing?
We do, yeah, absolutely. We talk about makeup air requirements to make sure that we're bringing air back into the building if we're creating a negative pressure situation. It is a code requirement if we're over ventilating for any reason. If we have a really high CFM exhaust appliance, typically it is a kitchen range hood. Not always though, but it is quite often a kitchen range hood. And if you've got that large appliance that's exhausting and you're starting to create a depressurization situation, then you really have to be cautious, and you have to apply the correct solution for that, which is typically makeup air. Right? If your fan is running at, let's say it's 1200 CFM that you're exhausting at, you may be required to bring 1200 CFM of fresh air in from outside. But guess what? You can't just dump 1200 CFM to the building, you have to warm it up, right? You gotta warm it up.
Have you guys ever thought, because your checklists are, for forced air, HRV, recirculated, and passive, have you guys thought about doing a separate checklist for renovation where the HVAC system may not be being touched, but it's a full kitchen remodel? So we sometimes see that, and we'll usually, if it's a large increase in the CFM of the fan, ask for the checklist, but there isn't necessarily a specific one. When we get back, we're not touching the HVAC systems, and we're basically hearing back from, well, we're looking for confirmation of whether or not we need makeup air, because you've got the naturally aspirated lines that you're increasing that fan. So I don't know if you guys can examine doing this separate.
We haven't, it hasn't come across my desk, so to speak. I haven't actually had that request come up, because I do find that this form can be applied to the renovation market, even though they may, there might be a little bit of exploration required by the contractor. What type of fans does he have in there existing? What type of exhaust fans are in there? Roughly what size of ductwork is in there? But you're going to come in as the AHJ, and you're going to look at this and you're going to say, well, this is all existing stuff. There's nothing we can do to change it anyways, right? If it's like early 80s through the 90s, the ductwork is probably all undersized anyways, right? And before that even, right? It's probably undersized, especially on the exhaust fans, if they even exhaust to the outside, right? Some of them even just dump into attics and that. So really, where do you draw that line? If they're doing a kitchen reno and they're going through the trouble of going through permitting and inspections and everything for a kitchen renovation, as inspectors, do we want to cause the general contractor more grief by starting to look at bath fans and look at that. Maybe what we need to do is maybe we need to make some sort of a, whether or not it goes with this initial checklist, but make something for the renovator, for the renovation market, and something that maybe gets that the general contractor can take away when he applies for his building permit, so that he knows that, hey, this may be an issue. Because I see that one all the time. I see that one I get a lot of calls for people that are like just about done their kitchen reno, right? So I'm just about done my kitchen reno. I need a gas contractor to come in and hook up my gas range, and I need somebody to put my hood fan in. And you show up and they got a 1200 CFM hood fan with a 5-inch duct that goes to the outside. And I know for a fact that is not going to move 1200 CFM, and it's going to be noisy, and it's going to waste energy, and it's not going to work. So we get into that situation quite often. And then the flip side of that is it's usually an older home, and it probably has naturally aspirated or NAFA appliances. Dangerous situation, right? We don't want to drive these guys underground by creating a market where they're going to have to do a whole bunch of extra work and maybe get priced out of the job, right? We don't want them to have to look at all these bath fans and everything. So what's the happy medium? I don't have an answer for that. But working with you guys, I'm sure we can come up with one, right? So definitely interesting aspect. But yeah, from the renovation standpoint, maybe we do need a supplement that goes along with the main checklist. It says, maybe existing bath fans and stuff, we're not going to look at those. But what we're going to look at is we're going to look at the size of the building. What's the total interior volume of that building? What does half an air change look like? And how big is that exhaust fan? Are we going to depressurize, right? The other thing is TECA also allows us to use depressurization testing, fan door test. You guys have seen this, and it's going to come up more and more as we go down the road of step codes. But when we do fan door testing, we're checking for depressurization, right? So when we're checking for depressurization and building leakage, that is another route that a builder could go. Go ahead, put the 1200 CFM range hood in. This house was built in 1965, and it leaks like a sieve. We're not going to depressurize it, right? So there are some options there as well, and maybe if those options were brought to the attention of that general contractor, we might be a little more successful in mitigating these problems.
Typically what we'll do is we'll give them the options. We're aware that it's an option.
Yeah.
This is either makeup air
or depth test, yeah.
I'll sit there and tell them, I know your house is probably going to leak, but we need to demonstrate we've done our due diligence, that we've validated that it is leaking, depending on the size of the renovation. But I find typically the contractor just defaults and wants to go get the makeup air. I don't want to risk not passing the blower door test and then spending more money to go back and do the blower door test and then the makeup air.
Yeah, I like it when people do it right. You're going to put in a big exhaust fan, let's put the makeup air in. But if you don't need it, it's a waste of money. And think of the energy consumption, right? Like that's what I look at. I look at energy consumption. We try to remain green as contractors, and we try to suggest systems that are going to be as energy efficient as possible. And we go ahead and we do something like this that throws so much energy out the door, it's crazy. Lots of times it's more practical to upgrade that heating equipment than it is to put in makeup air. Right, especially if you're talking about multiple kilowatts of makeup air, of heat energy that needs to go into it. So it's a balancing act. It really, really is. And the more we can educate the general contractor, the builder, the renovator, even more so than the HVAC contractor, those are the guys that need to identify this stuff at the beginning, right? When they're getting into these types of projects. I mean, yeah, it's one thing to learn by going and doing the work, but the more you know, the more you're educated beforehand, the less problems we're going to run into. So it's a great question, and it's super valid, especially with the market the way it is, and there's so many renovations on the go. It's like a $4 billion industry across the country, I think, something like that, maybe more. That's our worksheet there, and again, we'll come back to worksheets at a later date when we get a chance to talk about that renovation form, and if you guys want to see any improvements to these forms that are going to make them easier for interpretation. So the guidelines course is designed to provide the contractors, inspectors, and suppliers and utilities with a skill set to identify, design, and install. The objective of the course is to maintain the minimum standards, and the focus of our training is to help industry to understand the importance of these standards. We want to avoid the pitfalls of incorrect and poor installations. All of our TECA courses are designed to help contractors, help building officials, help builders, and provide homeowners with safe, reliable, cost-effective systems. They'll provide comfortable indoor environments. And our systems are designed to be fully inspectable, which I just said, and I'll keep hammering that home, but let's do our work together and make them even better. And our design forms become the permit submission and inspection checklists. So I have a question and answer period. I don't have a whole bunch of time left, but I also want to show you, everyone in the room, another thing that we're working on with TECA, with our website, with the Builders Officials resource. But I will take a few more questions and answers for maybe a couple minutes before I dive into that. Is anyone working with contractors, anyone run into some really like major issues, like some real deal breakers, or contractors that you have been working with that are really not wanting to do their job correctly, that are not wanting to comply? Because we're running into this a little bit more at TECA with contractors that are maybe abusing their ability to design a system and install it correctly. I heard about how much time have we got? Yeah, right. So everyone has probably hit a wall with an occasional contractor that comes along. Well, we want to hear about that. We want to, at TECA, we want to know what contractors what contractors maybe shouldn't be, right? We want to know about these guys. And with that being said, we've got a resource that we're putting together on our TECA website where we have the ability to, because TECA owns their certificate. We certify them, but it's up to us to make sure that they remain certified. And if they're going to not comply with the code and they're going to do installations that are incorrect or unsafe, and they're going to consistently do this type of work, we are going to revoke their certificate. We're going to suspend it. And with the suspensions, it would be very good for the building official to be able to know if their HVAC contractor or their ventilation contractor has a valid license or a suspended one. So what we're starting to do is we're putting together a section on our website where we've got a list of contractors that may be under suspension. How many do we have currently? One person under suspension in the province? Just one?
The first trial 1 month ago, just executed, and that is just the first.
You executed them? That's pretty harsh.
His competitors would wish we had.
Not to mention the homeowners down the road too, I bet.
Those two.
Yeah, exactly. So that's what we want to avoid, right? We want to avoid the pitfalls of poor installations. And we all have, every municipality has at least one problem contractor. Hopefully you can work with them and educate them and get them to a level where you can work together. But if that is absolutely out of the question, at TECA here, with your support, we will suspend contractors from doing this type of work. Now you got to remember, this is a big deal. If you suspend someone from doing something that they are making a living at, this has a lot of legal implications, not just for us at TECA, but also for the municipality. So we don't want to take this lightly. Hopefully we can fix these issues with the contractor prior to us having to create a suspension, but it's a very, very costly process, and it can be very stressful for everyone involved. David, yes?
Basically, a suspension is preceded by a letter of warning. 12 months later, if it's not been corrected, he will be suspended. His cost of reinstatement will be $1,000 by the time the dust settles. The suspensions are 6 months, and they'll be posted on TECA's website under inspectors, and this has been released to your association, and if it isn't, it will be shortly on your website as well.
Okay, so I am going to pull that website up and just hopefully, and this is new to me, so bear with me, and my mouse isn't working, so it's extra tricky. Okay, so here we are. I'm at the TECA website here, and what we've got is across the top of our TECA website. Pardon me. We've got a number of drop-down tabs up here. We've got our memberships. This is member information, courses that we offer, some products links. But up here you'll see there's a new tab on our website, and this little beautiful addition is really in the works as of midnight last night. We were still working on it to show it off. But basically in the inspectors section there'll be a login area for inspectors, and the building officials will be given login information so that they can come in here and take a look. And what you'll see is you'll when you first, do I have to log in again? Maybe not. When you first come here, you'll see that what we've done is we've categorized it into our primary sections to do with all of our, whether it's hydronics, the HRV course. These are kind of overviews of the courses But what you'll find in here is you'll find a lot of practical information. Now, since I'm a ventilation instructor, I will start on the ventilation, the building officials section for ventilation. Oh, and this is going to force me to log in. Shoot. One sec. So basically, the login credentials you will get. And when you're logged on as a building inspector or as building official, I should use the proper terminology, you're going to find some resources here for you. So basically, there's some information in regards to our certification and the 2012. This is something to do with the extension. This is what the current stamps look like. There is a letter there. I'm not going to bother opening it. Ventilation checklists available for download. The most current versions of vent checklists are on here. So those can be downloaded as well. Right directly from our site, and there is a ton more content coming as well. The part that I really liked on this, which we recently saw, and I don't know if I should actually show it off or make you go here yourself, but we've got our certification suspensions here listed off. So this is where you're going to find anyone that's currently suspended. I don't really want to open it right now because I'll let you look into finding out. I don't want to advertise who we've suspended. Basically, I don't think it's very kosher to do that. You'll also find a list of our Q1st or Quality First contractors in here as well. You'll find an alphabetized list, or you can search by your region, or if you know part of their company name, you can look them up. And what you're going to find in here is you're going to find the company, for example. I should maybe use my own, but am I under page 3? Just so
Are
that
you in good standing on that list?
I think I should be suspended for talking too much in class. Anyways, as an example here, we've got New Era here from Garibaldi. They are currently certified. Oops, squeezed through there too far. But you can see where they're certified. That is a ventilation certificate. That there is a Principle of Moving Air, or the POMA course, which is a fabulous course, and they also have an HRV, or Heat Recovery Installers course. So you'll see all of their certificates across here listed off directly with their company name, where they're located, what region they're working out of, and we have a login area as contractors as well. Question back there.
I think the approach is actually wrong. You should actually notify the jurisdiction that you suspend this person so they know. Like you say, you want to keep a secret. Well, this person can keep on working. We don't know if he's suspended or not. We're just going to keep on taking his papers.
Can you comment on that, David, Catherine?
Yes. Without naming names in New Westminster, which were involved in suspension of this one Surrey contractor, they know throughout the department who it is and when it happened. Also, a copy of that suspension was sent to New West and also to the OABC for posting. The question that you're asking of did it go uniform beyond that is, of course, that contractor would work in many other municipalities within reasonable travel distance. And that's why the best we could do is send it to your association for posting on your site.
And then if you go under consumer information query, that drop-down tab, there's a suspension. You drop down under suspensions, it'll show the person that's suspended.
Yeah. What do you think?
Go for it.
All right. So here's where this. Oh, good. It cuts it off. This is what the page looks like. This is where you're going to find this under consumer info. And I like the fact that it's under consumer info, and you don't need to log in to actually see this, because if a lot of homeowners act as their own general contractor, and I like them. A lot of them are using the BBB, the Better Business Bureau, and stuff like that to look into their contractors that are doing the work for them directly. Hopefully, they come to the TECA website and find out this type of information. However, as an example, with the person that's been suspended, I'll bring it up here just so you can see. This is what it looks like. So this is the suspension, and you'll see it was active as of October 1st, 2019, and you can find out more details. Might as well go the full. So you can find out what the company name is, what the primary in that company is, what their ventilation certificate number is, the date since they've been suspended, and also any notes directly from TECA. So it says here, we strongly urge you to reject any ventilation guideline checklist submitted by this individual. They are currently suspended on our behalf, but unless the municipality knows that this contractor is suspended, you're just looking at a stamp, right? You're just looking at a number on the stamp. Hey, it's a triangle, it's current, away we go. So you're right.
From the grapevine that this contractor has now done work in Squamish and he's venturing as far as Pemberton. You can run, but you can't hide.
You can run, but you can't hide. Well, hopefully he keeps running, right? Keep going west, my friend. At any rate, I don't like to pick on people when they're not here to defend themselves, but at the same time, too, this is a valid scenario. I believe this is the first time it's come up with TECA, but I tell you, from some of the stuff that I've seen in the trade and from some of the reports we're getting back from municipalities, it will not be the last, right? We want to enforce quality installations of ventilation, and we really need your help to make sure that this gets upheld, these guidelines get upheld. Remember, this is the minimum standard, right? People can build better. You can do better jobs. These are the minimum standards, and if you can't uphold the minimum, maybe you're in the wrong business, right? Not the building officials, but the contractors. We want to make sure the bad contractors get rooted out, because everyone suffers, right? Everyone suffers. So I really like where we're headed with the TECA website and with the inclusion of everyone that's involved, whether it's the contractor, the trainee, or the building official. That I really like the direction we're taking with this, and I think it's going to really create a new dialogue for us and a new direction for TECA to take on in regards to. I hate using the word policing, but that's ideally what it is. You're our forces out there in the field, and we're just in the background trying to make sure that all the contractors know what's requested. There's other cool stuff on our website. I encourage you to check it out, to cruise around. Our courses that we offer, we've got a great field of courses. I'll just quickly touch on those because I think they're fabulous, and I believe that building officials get a reduced rate. Is that correct?
Corey,
yes.
We posed a question to this audience. We've outlined some of the things that we have on the building officials section of our site. Are those of you who are listening to Corey have other suggestions of what we might include that would help you?
And can we make notes of that? I can do both. What else should we have included in there? So we've got an area where we're talking about contractors that come to our attention at TECA in regards to suspensions. A lot of stuff for consumers, things to know, how to hire a contractor. Hopefully this is for the builder and the homeowner that's doing their own building. We've got a list of our Q1st contractors. And in the inspectors area,
You have a report in the inspector's area. So say there is someone who is consistently doing this, that we can just go to a report post to you guys.
It's a good idea. If you have some way, you want a reporting mechanism to report back to us.
Yeah.
You have a contractor that's a total, one of those guys.
Yeah, like you open up your
yes.
door there and it's okay. Here's a report, just a thing, name, what the name of the municipality, inspector, what's happened.
You can email a PDF of the documents as an example.
Like upload examples. Okay, good stuff. Any other thoughts of what you'd like to see in there? We want to put as much resources in there as possible, and we want to see you use it, right? I would like to see a lot of the information that's in this manual, information that David and the committees have put together that isn't available anywhere else other than in this manual. I would like to see it in that inspector's area, but we also don't want to bog you down with a whole bunch of stuff you're not going to use. Right? So, I mean, in this manual, there are case studies in regards to whether it's the effectiveness of fittings, to case studies of what happened with carbon monoxide poisoning, to, I mean, there's so much information in here. It's a great read, especially from that standpoint, from the builder or from the building official's standpoint. But definitely, some reporting forms is a great idea. So that we can maybe get our radar going on these contractors that aren't performing at a level they should be. Any other thoughts that we'd like in there? I think that the intent with it is to give you the resources so that you can support your field operations and your permitting processes. That's kind of the intent that we have. However, we would love it to be turned into more of a community where we all have there's some back and forth and how we can improve to make your jobs better, easier, faster, more productive, and feedback from the field in regards to what you'd like to see changed and what you'd like to see updated. So definitely. So the reporting mechanism is a great idea for sure. Any other thoughts? I know it's just dropped on you. I know lots of time you're going to be laying in bed at 10 o'clock tonight. It's going to go, oh shit, I should have said this, right? I think that all the time. I'm handing out my card at the end? Yeah, sure. Absolutely. You can get me right off the TECA website. I'm on there somewhere under Jackass Instructors. But the nature of it is, and I've been fortunate enough to have a few in the room that have actually done a class with me, and we have a lot of fun in our classes too. So it's not all just the drudgery of trying to learn how these systems go together. But we actually talk a lot about installations that have been done, and jobs that have gone astray and jobs that have gone really well. So, Catherine, do you have something to add there?
Yeah, we also offer customized training for building officials. So if you have people in your office who want to affiliated training in one of our courses, just reach out to us and we can arrange that.
Absolutely. And one thing I've noticed with any building officials that have been in our standardized classes, I teach typically the ventilation guidelines course, and I've taught a couple times the new HRV course that we have available. And the HRV course, I highly recommend it. I really enjoy taking it, and I really enjoy being an instructor for that as well. And I learn a lot from other contractors during the class, but I've had a lot of building officials, and I don't know what it is, but they don't have to write the exam at the end. So it's kind of like, they get the best of both worlds. They get all that education come to them, and they don't even have to prove that they know anything. So it's pretty wonderful, right? So, and they get all the power. So it's I know, it's awesome. Are you guys hiring? At any rate, there is a lot of work left to be done on our TECA website to support you as the building official. We've done a really great thing for supporting our members and supporting ventilation contractors, but now I think the most important, or one of the most important parts of that circle has started to be filled in with the inclusion of the building officials. And I'm really excited to see a dialogue start, and the more of a word we can spread about TECA and what we do and what our intents are, I hope that we're going to get that conversation really going and keep it going over the next number of years, because there's still a lot of work to be done when it comes to indoor air quality for residential builds. And for those of you that don't know, TECA, we've started to we're striking out into other parts of the province for more training opportunities for contractors and building officials and the like. We ran a program we did Cranbrook this year, so we were up there and in that part of the province, and we are actually having a meeting this afternoon to try to figure out in the new year some other areas that we're going to strike out and have TECA's presence in, because it's really difficult for contractors and building officials and anybody in a regular job to get away, come to the mainland to take a 1 or 2 day or 3 day training program. It's really quite tricky. So the other thing we're doing too is we're trying to pair those training programs off so that if it's a number of 1 or 2 day courses, that they're all in a row. So we could send one instructor up, teach 2 or 3 different courses, and have everyone come in and just back to back get their certificates going. So it's been really successful. I thought we had a great success. I had a fabulous class and really engaged students when I ran the Cranbrook class earlier this year, and I hope to be a big part of that moving forward, getting this education out there. For me, it's all about education. Catherine, yes?
I just was going to say as well to the members in the room, if you find there is a need in your area and you're looking for some of this training, please let me know, and I will work with you in your area to get that training out there. Work with your zone directors to ensure that you guys have those opportunities. So don't hesitate to get a hold of me, whether it be TECA's training or any other type of training that you guys are needing. Please send me an email, let me know what's needed, and we'll work together and get it to you.
That sounds really good. Okay, so that's it for me, unless you have any more questions. Anybody have any questions or any things they'd like to add? If in the meantime, too, if you do come up with something that you'd like to see as a resource for the building official on our website, you can get us at Office at TECA. It's right there on the website. There's a link that you can get to. And if you go to your Google search page, Safari, whatever, and type in TECA, TECA, guess what? You'll get to our website. So it's really easy to find us. And we're out there. If we don't have any more questions, I'm at my time limit almost to the second. But I will, burn up somebody else's time for a few minutes and take more questions if you have them, or comments even. So far, so good? Okay, to wrap it up, I'm Corry Martin. Thank you for your participation.